Next point from the solid state is unit cell lattice point. So what is mean by lattice? The lattice, that means what? Regular arrangement of constituent particles in 3D or regular arrangement of point is called as a lattice. What is mean by lattice? The lattice means regular arrangement of constituent particles in three-dimensional. It is called as a lattice. Or you can simply say that regular arrangement of point in 3D, it is called as a lattice. Okay, that means what? You can simply take these atoms. I can arrange these atoms in a regular manner, and simply I take here one atom here, then between these two, then correct below the first, like that, below the first atom, like that. You can simply see here मी काय केले, रेग्युलर अरेंजमेंट केलेली आहे and between two this atom 3D मध्ये मी ॲटमची काय केलेली आहे, 3D मध्ये अरेंजमेंट केलेली. अगेन इन थर्ड स्टेपला, थर्ड लाईनला बरोबर फर्स्ट ॲटमच्या बिलो तो ॲटम, नेक्स्ट स्टेपला बरोबर सेकंडच्या बिलो, लाईक दॅट. सेकंड ॲटमच्या बिलो 3D डायमेन्शनल अरेंजमेंट केलेली आहे. याला आपण म्हणतो लॅटिक्स. लॅटिक्स म्हणतो रेग्युलर अरेंजमेंट ऑफ कॉन्स्टंट पार्टिकल इन 3 डायमेन्शनल or regular arrangement of point in 3D. It is called as, this is called as a lattice point. This point is called as a lattice point and this is called as a lattice. Okay, तर आता मी एखादा रेग्युलर अरेंजमेंट करत असताना I have taken here simply 4 atoms can join together. Here also I can, this 4 atoms join together and this points you can join here completely. Okay, this is the one unit cell. All atoms are joined here in a 3-dimensional and this part is called as a unit cell. Again I simply join this atom below this atom. I joined here, all point here. This is simply one unit cell. So what is the unit cell? The smallest 3D unit which can form lattice after repetition. आता युनिट सेल मीन्स व्हॉट? युनिट सेल काय असणार आहे? युनिट सेल म्हणजे काय? द स्मॉलेस्ट 3D डायमेन्शनल युनिट which can form lattice after repetition. That means what? It is the smallest repeating unit. It is called as a unit cell. It is the unit cell means what? It is the smallest repeating unit. You can simply again see here. This is lattice. Here it is your lattice, and I arrange all point in a 3-dimensional. Second line in between these two, and again this first, again below this one I can arrange this point like that. So this arrangement is the 3D dimensional arrangement of that point. Okay, I can take here one, this point can join together again here I can take here these 4 points. I simply joint here all corners like that. Okay, like that. Here one atom. Again neighboring atom I can take here. Here also this one. And all atoms joined like that. This is simply, you can say that this is single unit, single smallest 3D unit which can form from the lattice which after repetition. म्हणजे हे जे तुम्हाला हे युनिट दिसतंय, हे जे युनिट आहे हे युनिट परत रिपीट झालं इथे. असंच पुन्हा रिपीट होणार आहे. म्हणजे अनेक साऱ्या स्मॉलेस्ट रिपीटिंग युनिट come together and form a unit cell. You can also define the definition of unit cell. Smallest but complete portion which smallest but complete portion which repeated over and again to make space lattice. You can simply see here, lattice means what? 3-dimensional arrangement of constituent particles. It is called as a lattice, and that points it is called as a lattice point, and 3D-dimensional arrangement is called as a space lattice. म्हणजे ज्या युनिट सेल आहे ते एका पर्टिक्युलर 3D मध्ये अरेंज केलेले असतात. स्मॉलेस्ट बट complete portion of which repeated over and again to make a space lattice. That means what? You can see here simply. This is your single unit cell, and this unit cell arranged in a 3D dimensional. You can see here. Your unit cell are arranged in a 3D dimensional. That means this is called as a space lattice. You can see here your unit cell are arranged in a 3D dimensional, and this arrangement is called as a space lattice. And unit cell means what? Smallest but complete portion which repeated over and again to make a space lattice. Okay, you can simply say that 3D dimensional arrangement of the unit cell, it is called as a space lattice. You can say that lattice means, you know, that 3D dimensional किंवा regular arrangement of the constituent particles, it is called as a lattice, and this point is called as a lattice point. Okay, and this point can join together form a unit cell, and the 3D dimensional regular arrangement of this unit cell, it is called as a space lattice. Lattice means structure made of strips which cross each other diagonally, and a collection of all the points in crystal having similar environment. It's called as a space lattice. Space lattice. You can simply here take one point, this 1 point, 1 point. It's a environment of all points are the same. That's why it is called as a space lattice. Okay. Ata you know that the type of unit cell, or there are total. There was a French mathematician Brevis proved that lattice point can be arranged in a maximum 14 types. Brevis lattice are arranged in 14 ways. Why? This arrangement can Brevis lattices can arrange in 14 ways. आता ब्रेविस लॅटिक्स का म्हणायचं? कारण जो फ्रेंच मॅथमॅटिशियन ब्रेविस नावाचा सायंटिस्ट होता, it can prove that lattice point can be arranged in maximum of 14 types. तर डिपेंडिंग करतं की त्याचं जॉमेट्रिकल शेप असेल ऑफ द क्रिस्टल लॅटिक्स किंवा ते जे लॅटिक्स पॉइंट असेल त्यांची अरेंजमेंट असेल तर ती डिफरंट असेल प्रत्येक युनिट सेलमध्ये. तर ती वाय इट इज डिफरंट बिकॉज ऑफ इट्स द एज लेंथ angles and all edges are same or different or angles are same or different. I simply say that French mathematician Brevis proved that lattice points can be arranged in a maximum of 14 types. This arrangement is called as a Brevis lattice. That means what? Lattice point can be arranged in 14 ways and it is proved that Brevis, that's why it is called as a Brevis lattice. Okay, तर आता because of the different edges and angles there, you know that this is cube. In a cube all edges are same. This is your cube. Okay, this is your cube. In a cube all edges are same. A is equal to B is equal to C. Okay, म्हणजे A ही जी edges, all edges are same. All edges are same and the angle between these two edges, these two edges and these two edges are same. That means all angles are 90 degree. That means alpha is equal to 90 degree, beta is equal to 90 degree and gamma also 90 degree. The constituent particle of the crystal can be arranged in 7 different ways. आता तुम्ही जर पाहिलं तर there are different types of Brevis lattices. Why it is the 14 types of Brevis lattices? Because 14 types arrangement of the lattice point. That's why there are 14 types. Okay, 14 Brevis lattices. But the constituent particle of the crystal, म्हणजे जे काही constituent particles असतील क्रिस्टलचे तुमचे, तर can be arranged in 7 different ways because by changing edges and angle to form 7 types of unit cell. Depending upon their edges and bond angles, there are 7 ways you can arrange your there are 7 types of unit cell because of the constituent particle of the crystal can be arranged in 7 different ways. Because you can see here this is cubic structure, all edges are same. A is equal to B is equal to C and alpha, beta, gamma all are 90 degree. That's why there are first type simple cubic. Then in case of second types of the unit cell, 7 different ways. The second type is tetragonal. The tetragonal, and which what happened in this case, you can see here all edges are not same. Here A is equal to B but B is not equal to C. म्हणजे A आणि B ह्या दोन्ही edges same आहे tetragonal मध्ये, but B is not equal to C and all angles are 90 degree, alpha, beta, gamma. Okay, you can simply see here the angle of alpha between edges. हा जो alpha angle आहे, it lies between edges B and C. Angle of beta is lies between A and C. Here C, A and C, and gamma lies between A and B. Okay, like that. So in simple cubic structure there are all edges are same and bond angles are 90 degree, but in case of tetragonal there are A is equal to B edges but not equal to C and all angles are 90 degree here. Then third, orthorhombic. Here A is not equal to B is not equal to C, म्हणजे all edges are not same but bond angles alpha, beta, gamma is equal to 90 degree. Discuss here 7 system of crystal lattice which with the 14 Brevis lattice. The first one cubic, second tetragonal, then orthorhombic, then fourth one monoclinic. Here monoclinic, all edges are not same. A is not equal to B is not equal to C, and alpha is equal to gamma. Alpha is equal to gamma is 90 degree, but alpha and gamma both are the same 90 degree, but beta is not equal to 90 degree in case of monoclinic. Okay, they're the simple types of crystal lattice. Then next one, fifth is hexagonal. In case of hexagonal, there are A and A is not equal to triclinic, extremely sorry, monoclinic I already discussed. Then triclinic. In case of triclinic, A is not equal to B is not equal to C, alpha is not equal to beta is not equal to gamma. म्हणजे काय, ह्या तीनही edges are not same and also bond angle are not 90 degree. This is your simply triclinic. The types of crystal lattice which are depends upon the edges and different angles. Because of 7 ways you can predict the crystal lattice, and with 14 Bravais lattice. This is the simply triclinic. The next one is hexagonal. The hexagonal, in case there is A is equal to B but B is not equal to C. A and B both are same edges but is not equal to C, and alpha is equal to beta 90 degree, but gamma is not equal to 90 degree, it is 120 degree. You must remember all the equality of edge length and bond angle, and depending upon you can predict the which type of the crystalline lattice there. Then last one is rhombohedral. The rhombohedral, there are all edges are same. A is equal to B is equal to C. Alpha is equal to beta is equal to gamma is not equal to 90 degree. So you have discussed here 7 system of crystal lattice with 14 Bravais lattice. We will discuss one by one. Okay. तर आता ऑलरेडी आपण 7 टाइपचे जे काही आपले ब्रॅव्हिज लॅटिक्स आहे क्रिस्टल लॅटिक्स आहेत ते डिस्कस केलेले आहे. तर नेक्स्ट व्हिडिओमध्ये आपण टाइप्स ऑफ युनिट सेल, देन क्युबिक लॅटिक्स, टाइप ऑफ क्यूब, देन अदर 7 जे तुमचे क्रिस्टल लॅटिक्स आहे त्याचे सब टाइप्स विल डिस्कस इन नेक्स्ट व्हिडिओ.